Hey Cougars, it's Mr. Franklin, and in this video I want to do a quick review of making a rule. So when you see that in the lab, what we're basically looking at is what's the mathematical rule that we're seeing, and we're creating this by looking at the data table. Another way that we will do it in this class is by looking at the graph. We've already done one version of that, which is calculating slope. We can do another version where we calculate the area under a graph. But in this case, we're going to look purely at our data table and kind of try to figure out what's the relationship between these numbers expressed as a rule or expressed as a mathematical equation. There are two basic ways to talk about this. And the first one, it's kind of hard to read because of the glare, but is unit analysis. So as a beginner, that's probably where I would start, is looking at the units that are involved and figuring out how they're connected, and then coming up with the rule based on that. The other way is to do a mathematical analysis where we're purely looking at the numbers and then going back and looking at what those numbers were representing. So let's take a look. So let's do dimensional analysis first. So the first thing I do is I look at what I'm working with. So I've got time, acceleration, and velocity, and I look at their units. So let's say I have time, which the units for time is seconds, and then I have acceleration, so the units is meters per second squared, and velocity is meters per second. Now for this class, because we're keeping it simple, when we're making a rule, first thing you should do is write it down, because some of this you will be able to see just by looking at it, but some of it you'll have to write it down, because otherwise you're going to have to hold your thinking in your brain, and that means you can get confused, you can get lost, you can repeat yourself, and while you think you're saving yourself work by not writing it down, it's actually taking longer. So write it down. So we're going to try one first. Let's try velocity times time. So let's do velocity times time, but from a unit standpoint. So we got meters per second times seconds. What does that equal? Well, seconds divided by seconds cancels, and we're left with meters. Does that get me the one that we did not use? So we didn't use this one. Does that equal that? No, it does not, so it's wrong. But now that I've got it written, I don't do that one again. So now I'm going to try a different one. So we did velocity times time. Let's try acceleration times velocity. Now, hopefully you can already see that this one won't work, but let's go ahead and write it. Acceleration times velocity. So we've got meters per second squared times meters per second. Meters times meters is meters squared. Second squared times seconds is seconds cubed. That's not even close to the thing that was missing, which was seconds. So that's not it. Okay. So now I'm going to try one of the ones I haven't tried yet, which is acceleration times time. So acceleration times time, which is meters per second squared times seconds. One of those seconds cancels, and I'm left with meters per second. That works because I did not use the velocity. This is the rule that we came up with just by using our unit analysis. Pretty cool. Okay, so the other version of dimensional analysis that you might have to look at real quickly is one where it's a derived unit we're looking at. So we've got force in newtons, mass in kilograms, and acceleration in meters per second squared. Now you can multiply those all you want, and you won't figure it out unless you realize that newtons is actually kilograms times meters per second squared by definition. Well, that right there tells you what the relationship is. So we've got force equals mass times acceleration. Newtons equals those two multiplied together. Okay, so in more complex versions of this, you have to be careful because a newton is those things. Okay, so keep that in mind when we come back to it. I think it'll make more sense in the future. All right, so back to this one. Now let's take a moment to do this with just the numbers. You should, at this point, you should just start with multiplying and try it out and see what happens. In the future, you may have to do some other things like you divide, try subtraction, try addition. But in this case, we're going to start with multiplying. So just for example, I'm going to do these two first. So what's 9 times 7? That's 63. Is that even close to what we have over here? No, so that is wrong. So not those. So what's this times this? So 7 times 0.78. Well, that's even smaller than 7. Is that even close? So that's going to be what? 49, 53 something? In other words, it's smaller than that number, so that's not right. So if I multiply this times this, it equals that. And so that's our relationship. Time times acceleration equals velocity. Okay. So that's the easy way. Here's another way to look at it, especially if you find out that one of your numbers is constant and unchanging. If all of your numbers are changing, it's a much, much harder issue and this may not work. But if both of these are, if this is constant, then all I have to look at is what's the trend for the time value. These values are getting bigger, they're increasing. What's the trend for velocity? Now, in math, we would say it's decreasing because it's becoming more negative. But in physics, all the negative means is direction. So it's the value is getting bigger, but it's going in the opposite direction from positive. So this is actually increasing because the value is increasing. It's just going in the opposite direction. So that's a subtle difference because negatives mean direction. Okay. If they're going in the same trend and one of these is constant, then you can set them on opposite sides of an equal sign. You can put the equal sign in the middle. And now you just have to figure out who gets multiplied times the other value. So if this is constant, we could try this times that. Nope, that didn't work. Or that times that. But if they go in the same direction, they're going to be on opposite sides of the equal sign. If they go on, if for example, like that one over there, if they go in the, yeah, they would still go in the opposite direction. If they go in opposite directions, more than likely, they're actually going to be on the same side of the equation, but they're going to be multiplying times each other, okay? Which we don't have, this actually doesn't work in this case because of the way the values work. But you could also have that. So if the trend is opposite, then they're on the same side, multiplying. If the trend is in the same direction, they're on opposite sides of the equal sign. And you multiply times the constant. That's basically two major ways to look at it: dimensional analysis or analyze the numbers. There are also two ways to analyze the numbers. So I hope that helps with doing the make a rule, come up with an equation as part of our labs. So that's all I've got for now. If you have any questions, please come to tutorial or send me an email. Thank you. Bye.